Hi, this is James. Today I'm going to show you how I solved this question. How many points are common to the graphs of the two equations? X minus y plus 2 times 3x plus y minus 4 equals 0. And x plus y minus 2 times 2x minus 5 plus 7 equals 0. So how I started is I know that for two parts to multiply to 0, one of them has to be equal to 0. So I said, well, if this first equation, x minus y plus 2, could equal 0, so x minus y plus 2 equals 0. And as well as the next equation, 3x plus y minus 4 could equal 0. So 3x plus y minus 4 equals 0. And then I said, well, also same for the next equation. So it could be x plus y minus 2 equals 0. And 2x plus minus 5y minus 5y minus 5y plus 7 equals 0. And then you can give, to make it clear, you can give each of these lines a number and a color. So call this line red, and we'll call it A. And the second line blue, and we'll call it B. Third line can be green, and we'll call it C. And the fourth line can be yellow, and we'll call it D. So you can graph these lines to find the common points. So I turned these lines into slope-intercept form. So line A would be y equals slope of 1, x plus 2. So that means the b, or the y-intercept, is 2, and the slope is 1. And then we do the same for the next equation. B would equal y equals negative 3x plus 4. So what I'm doing is I'm rearranging the variables by subtracting and adding x's and y's to both sides to make it slope-intercept form. So for C, we have y equals negative x minus 2 plus 2, plus 2, negative x plus 2. And then for D, we get y equals 2/5 x plus 7/5. And we get this by dividing 5 from the 5y into negative 5y, and then subtracting the 7 and the 2x, and multiplying 3 by negative 1. So now we can graph these equations. So create a graph here. There we go. All right. And then, so A and B both come from this equation. So A comes from here, and B comes from here. Then C comes from here, and D comes from right here. So when we graph the lines, when we graph A, we know that the y-intercept is 2. So you know there's a point right there. And you know the x-intercept, when y equals 0, x has to equal negative 2. So x equals negative 2. And since the slope is 1, you know that every point along the line that is going over 1 to the right and up 1 will be there. And then we can fill the line out just like that. And then you do the same thing for B. So for B, the y-intercept is 4. B is 4. So right there, there's a point there. And when y is 0, the slope is -3. So that means 1 to the left, up 3, or down 3, 1 to the right. So there's a point here at 1, 1. And since if you find the x-intercept, when y equals 0, it has to be -4/3, so it can add 0. So 1 and -4/3, or 1 and 1/3 would be right about here. And then we can draw the line for this. And it should look something like this. Okay, now we draw C and graph C. So the y-intercept is also 2. So there's a point right there. And the x-intercept would also be 2 because it's -x. It's almost the same equation as A, but it's the slope of -1, not 1. So we have a point here at 2, comma O. And then we can fill in the rest of the line like this, just like so. And then we can draw the line just like this. Alright, and then we only have one line left to draw, which is the D. So we know the y-intercept is 7/5. So 7/5 is going to be somewhere right around here. Somewhere right around there. And we know the x-intercept. The x-intercept is going to be 3.5 because when y equals 0, or pardon, negative 3.5, because when y equals 0, -3.5 times 2/5 plus 7/5 is equal to 0. So we put a point at 0, -3.5, which should be right here. Right here. And then we fill out the line. And that line should be right about here. Sorry, I made a mistake back here. That dot should not be there. And then we say, well, what is the question actually asking? The question is asking, how many times do A and B intersect with C and D? So we can count those points. So D intersects with B right here. And D intersects with A right here. And then we count the intersection points for C. C intersects with B almost at the same spot, right here. And C intersects with A right here. And those are the only intersection points. So therefore, the answer to the problem would be 4.